Okay, now that we know about population inversion, we know about gain mediums, we know about pumps, yes? So now let's discuss what's actually happening inside the gain medium. Okay, here we go. And remember, this is an oversimplified description of a laser operation. So this is where most atoms want to be, in its absolute ground state. These are called its pump levels. There is a problem. Do you see the problem? Also, there's many of them. Do you remember we talked about E2 minus E1 equals HF? Particular E2, particular E1, you need a particular frequency coming out. That will not provide it. So what we will need is for our particular gain medium to have two additional guaranteed levels. I'm going to call them E2 and E1. E2, let's call it upper laser level, and E1 will be the lower laser level. Oh, and then we'll call this one ground level. So our pump will elevate our ground state atoms into the pump levels. It could be E31, E32, E34, whatever, whichever one it is, right? Now, you have a lot of range for your pump in this situation. Good? Number two, you need a fast transition. You need your pump to have a fast transition into the level E2. So many of these electrons, many of these atoms, you would want them to stay at E2. The criteria for E2 is that it should almost be a metastable state, which means the atoms should stay in that state for a really long time, which is 10 to the minus 3 seconds, but it's eons in terms of how quickly these transitions happen. Okay? Then, when it settles there, if you have an external photon coming in, it should cause two photons to come out of this state. And the the atom will jump from state E2 to E1. And then finally, from E1 to ground state, it can just decay as it wants. We don't care. So what is the advantage of doing that? The advantage of doing that is it gives the pump time, not time, but like it doesn't actually have to be exactly 5 volts. It will still work with like 4.9 or 5.1. So it gives you a bit of a leeway in that scenario of which level it pumps it up to. But the fast transition, you are guaranteed the level that E2 is, and you are guaranteed the level E1 is. Make sense? So you are absolutely sure that those two levels will give you the two photons coming out. Are we good? Okay, so now let's write this down. Step 1, pump energy, take atoms from E0 to some E3, right? They could be any of the E3s. Step 2, fast radiation less transition to E2, which was called the upper laser level. The requirement for E2, number one, spontaneous decay from all E3s. Number two, radiation-less transition. Number three, metastable. That means atoms will stay in that state for a long time. So a long lifetime. The order is like 10 to the minus 3 seconds, which is eons when compared to the other levels. So what will happen? There will be a pileup of atoms in this state. So that means if I call the number of atoms in this state N2, then that means N2 will become large. Step 3. External photon with the right frequency, E2 minus E1, comes along. N2 atoms decay to N1 and stimulated emission occurs. Right? Instead of 1, 2 come out. For every single one of those atoms decaying from N2 to N1, 2 photons will come out. And the last step, step 4, atoms in E1 state decay quickly to E0 ground state and are ready for this process to begin again. Make sense? And this process gets repeated over and over and over and over. Again, this is a very simplified, very, very simplified version of what goes on in the laser. Yes?
What is fast radiation?
So this one?
No, just what the word is.
Yeah, that's what I was going to explain. So this transition is supposed to be like a fast transition, but it has to be radiation-less, which means no photons should come out of it. Radiation-less, right? The same way this transition from
E1 to
E1 to E0 should be radiation-less.
Gotcha.